Okay. So, hello everybody. Well, thank you for being here. And I want to talk or kick this off with deployments. Let's take a look at a deployment a few years back. Probably for most of us, it was like connecting to a machine, uploading our artifact, executing a few commands, most important step, hoping for the best, and the application would be deployed. Well, fortunately, nowadays we have found a much more flexible and scalable solution for doing our deployments. And I assume many, or probably even all of us in this room, are heavily relying on Kubernetes for pushing our workloads to production. So, since Kubernetes has been open sourced in 2014, the tool itself and also the way we are working with it has evolved a lot, right? And so today, it's not only our go-to hub for containerized workloads and services anymore, but it is really becoming the backbone of our internal developer platforms, allowing us to not only deploy services and applications, but basically to deploy everything we need to run them in production. No matter if that's infrastructure, if that's cloud services, if that's maybe observability dashboards, alert configurations, no matter, just what you need to run your service in production. And that's amazing, because for us as platform engineers, this opens up so many amazing opportunities to improve developer productivity, but also experience in their day-to-day life. But at the same time, we really have to be on our toes about security with that. Because let's face it, OWASP is not creating those vulnerability lists for fun, right? And if we take a look at the OWASP Kubernetes Top 10 from 2022, we will see that insecure workload configurations and overly permissive RBAC configurations are two of the three topmost items on there. So today we are going to explore how applying the principle of least privilege to Kubernetes can help mitigating at least parts of those problems. But before we do that, who am I actually to talk about all of that? My name is Katharina. I'm a software engineer at Dynatrace. At least that's what my job title says. Actually, I'm working in the fascinating world of DevOps, cloud native, platform engineering, and I just really enjoy it, and I also love being part of communities like this one. But I also have to make a little confession. I'm standing here in front of you talking about security in Kubernetes, and actually I'm by far not a security expert. And neither is my team, so why am I doing this? Well, the reason is we're managing a couple of Kubernetes clusters, and we want to make sure that they are running in a secure, stable, and reliable way. So we just have to care about things like security and least privilege. So what I want to do today is I want to share our journey, our very practical approach with you on how we are handling least privilege in our clusters. Okay, and with that being said, let me start with a really embarrassing story of our team. But I think it's important, so I thought I would just share it. So I told you we're managing a few Kubernetes clusters, and one of those clusters is responsible for the whole CI in our company. So there are around 40 Jenkins instances running in there, about 50 Renovate bot instances that teams can configure, a few Gradle caches, a few Sonar cubes. If a team needs some additional infrastructure for tests in their pipelines, they can spin it up in there. And it doesn't fit their scope, but also Backstage is running in there. And this whole cluster is deployed with Terraform, everything configuration as code. And when we deploy the cluster, we also immediately install ArgoCD and create one root application in ArgoCD. And this root application just follows the app of apps pattern and spins up all the other applications we have in our cluster. So here's what happened. One day we had a new developer. Let's call this developer Alex for this presentation. And Alex joined us. They were a senior developer and a really, really skilled one actually. But what Alex didn't have experience with was our system, because how could they have experience with our system? And one day this root application created with Terraform was degraded. Alex was alone in the company, tried to fix it, tried to sync it with ArgoCD, didn't get green again. So Alex went ahead, connected to the cluster, executed a few commands, nothing worked. So Alex had the idea, hey, this is GitOps. So why not go ahead, delete the cluster, delete the application, let it sync again, and it should be good. Well, what Alex didn't know, this is the only application not continuously reconciled because it was created with Terraform. So what happened? Alex connected to the cluster, did kubectl delete applications, really bad name, I know, and our whole CI was gone, just within a second. All our finalizers kicked in, all applications were deleted, the whole cluster was empty. It was not too bad. Because it was GitOps, we could restore it easily. Jenkins made a few problems because of it being Jenkins and not running stateless and stuff like that, but yeah, it was okay. The impact was rather low. We lost like half an hour of data, quite okay. But still, it wouldn't have been necessary. And what this story did to us is it finally gave us this push from being like talking about, hey, we should finally one day care about least privilege, but we never have time, to, hey, this is important, this could have been much, much worse, so let's do it now. And this is also the reason why I'm telling this embarrassing story to you, because maybe one of you needs this little push in the direction of getting started now, so if you need it, here it is. But how could the principle of least privilege have helped in this regard? To learn about that, let's take a look at the definition, or one of the definitions I found. And here it says that every program and every privileged user of a system should operate the least amount of privilege necessary to complete the job. So the first very important part in there is every program and every privileged user. This means least privilege does not affect users interacting with your cluster alone. It really affects everything and everybody interacting with your system. And the second important part, least amount of privilege necessary to complete the job. So of course you're not taking away all permissions. That would be stupid. Nobody could do anything anymore. But you're really taking away all permissions, all privileges that are not necessary. And this definition was the first one I found. It was mentioned by Jerome Salzer in the year 1974. So next year, it will be 50 years old. But still, in my opinion, it's more important than ever. Because we're building really complex and distributed systems at the moment. We're building microservices, some of us even micro frontends. We are building huge delivery platforms with self-service capabilities for developers. And with all of that, we really need to care about security and stability, in my opinion. So by applying the least privilege, we can make sure that the overall security of our system improves. No matter if an attacker does something malicious in our cluster, or if it's somebody like Alex just doing a mistake, the blast radius will get much smaller if you trim down the privileges. You also have much less attack surface when applying it, because even if an attacker manages to grab some credentials of your system, it will be only for one job and probably not for cluster admin, because you probably don't even have credentials with this privilege anymore. Malware propagation gets much harder, because how would you place a Bitcoin miner, for example, in a cluster if you don't have privilege to do that on the node? Stability increases, no matter if for mistakes or attacks as mentioned. And if you have any compliance rules, least privilege is part of it probably anyways. That's a pretty good start, we thought. So in our team, we decided, let's do that, let's implement least privilege, and let's get started with this in regards of security. But there is much more we can do, actually, and there is a second term that is kind of prominent in the cloud native space currently, and it is Zero Trust. And Zero Trust is a strategy that says no entity, whether inside or outside an organization's network, should be trusted by default. This means when somebody or something, again, is connecting to your system, you never trust it based on a certain attribute, like, for example, location, network, whatever. You really always go the full authentication and authorization circle and verify if this entity is allowed to do what it's intending to do. And this is one of the first three core principles of Zero Trust. So never trust somebody, always go the full circle, always verify. The second one, least privilege, I think we talked enough about that one. And the third one, my favorite one, is assuming breach. So with Zero Trust, you are assuming that breach will happen, you're preparing for it, and by doing that you can probably prevent lots of cases that happen, but also if you cannot prevent them, you will be much faster in your reaction and you will be able to resolve that much faster. Okay, that was a lot of definitions, and I'm sorry for that, but it was quite important to me. But let's get a bit more hands-on at least, and let's get our last player, Kubernetes, into the game. So in all definitions we had like no entity, no program, no user, so we had lots of subjects defined already. But what are those subjects actually? First of all, we have humans interacting with our cluster. We have developers, we have platform engineers trying to deploy something, trying to administer the cluster, just trying to keep everything running. Next, we have service accounts that we need to care about, no matter if from workloads inside our cluster or from workloads outside the cluster that would like to connect to our cluster. For me, when I got started with least privilege, those were the two most obvious ones. But then I started to dig deeper, and then I started to recognize there is actually so much more that we have to secure. Let's just think about containers and workloads. Many containers today are still running in privileged mode, and I believe that for most of them it's really not necessary to complete their job of running an image to run in privileged mode. But if an attacker would manage to connect to that container, they would have root access on the node, so really not least privilege. And this is just one example. There's actually a huge list in the Kubernetes documentation in the port security baseline, which tells a lot of things like that. So we really do not only need to care about users and things interacting with our clusters, but also the things running in our cluster. Well, speaking about containers running on nodes, the machines in our cluster, which tools do we have on there? If somebody manages to connect to them, which tools do they have available? Are all those tools necessary for running the cluster, or can we get rid of some, for example? Networking is always a huge part of least privilege. By default in Kubernetes, all pods can communicate with each other across namespaces. Definitely something you don't want to have, and definitely something you can limit with networking policies. And also something to care about that we forgot about in the beginning is extensions. So if you install any extensions, like for example operators, API extensions, whatever to your cluster, really do care about that they adhere to least privilege as well, because it always needs to be all parts of your cluster. If you do least privilege really well, and then you install an operator that doesn't do it at all, of course it's better than nothing, but still not the ideal situation. And just a few days ago, the WIS Kubernetes security report was published from 2023. And when taking a look at some of the items, we see that all of this is still very relevant. So we can see that some, even though with less than 1%, it's not much, but still some clusters still allow anonymous API access. 8% of ports of the 200 cloud accounts they analyzed still have elevated RBAC privileges. 16% have risky system capabilities. 18% either mount sensitive host paths or even run as root, as we just discussed. And more than 90% of namespaces don't have any network policies set. And by knowing that, and they also mentioned in their report that they did some experiments and they spinned up Kubernetes clusters in cloud. It took about 22 minutes for some other tool or scanner to recognize this and to try to connect to the cluster. So we really need to care about all of that for our clusters. But unfortunately, we cannot care about all of that in this talk today because we are nearly halfway through, and I think we could talk for hours probably and have a really interesting discussion. But what we're going to do today is we are going to focus on users and service accounts, especially because of this making users not hate you part. And the good thing is, for users and service accounts, there is something built into Kubernetes that helps us applying the principle of least privilege. And I'm sure you all know it. It's just role-based access control, RBAC. Basically, with RBAC, you define a role. In this case, it's a role living in the default namespace. It is called port reader, and it allows to get, watch, and list ports in the default namespace. And now let's say we want to assign this role to Alex, because actually all that Alex needs is to read ports. So let's create the role binding. Let's give it the same namespace, which is default again, assign it to the subject Alex, which is of type user, and reference the role we just created. And that's it. So we have a role that defines what can be done, and we have a role binding that defines who can do it. If we want to do that on cluster level instead of namespace level, we just use cluster role and cluster role binding. Super easy, right? A university teacher of mine would have said that second grade elementary school, peanuts. So, and I agree with him. But the thing about RBAC is, in theory, it's super easy, clear, and logical to understand. But in practice, it's like a maze of considerations. Especially when you have a running cluster already, you will only notice like how many workarounds you, your users, your workloads, whatever, are doing to actually get the job done. You will have lots of discussions with people using your cluster. And actually, it is just really, really hard to get this done in real life. I know it doesn't sound like it when you just look at role and role binding, but believe me, it really is, unfortunately. Luckily, there are some tools that can help us. What they can do is, first of all, you can use tools, for example, to visualize the current RBAC setup. So if you have RBAC in your cluster already, you can go ahead, create a chart out of your whole RBAC setup with all users you have, with all service accounts you have, and all the capabilities they have in the cluster. That's nothing that helps you much with setting it up, but it's actually a really good tool to create a kind of report and to have something you can compare against later on in 1 month to see how much you have improved, or also something that you can use as a base of discussion actually. Next, you can generate roles and role bindings from audit logs if you don't have RBAC configured yet. So there are tools that are analyzing your audit logs in your cluster and then generate some roles, role bindings, and of course also cluster roles and cluster role bindings for you. If you want to use that, of course, be careful with reviewing them before applying them to the cluster, but at least something that makes it easier to get started, in my opinion. And another very useful thing is they can identify risky permissions and generate reports out of it so that you again have something for comparison later on. Because in my opinion, if you don't have any way to measure something, it is really hard to improve it because you will never know if you actually got better. So those tools at least provide a good way of getting started with measuring this, or measuring how you implement RBAC and least privilege. But still quite cumbersome, right? And still really, really hard to do. So at this point, we have made a decision in our team. We have decided that we will embrace that for service accounts because we haven't found any other solution for that. If one of you has, please approach me, it would be awesome. But for users, we have another solutions. For users, we are trusting Git repositories instead. So what we want to do with our clusters is we don't have any user that has direct cluster access, but we're reading the full desired state from a Git repository and then apply it. So just standard GitOps. And one of the biggest reasons I like it so much is because we humans are really, really good in understanding complex systems. We're good in having deep discussions, developing amazing things like Kubernetes. But we are also super good in doing small typos, in doing copy-paste errors, in forgetting something. At least I am. And so if we trust Git repositories and always read our desired state from there, we can be sure that everything that is deployed to our cluster has gone through a pull request, has gone through the 4 eyes principle, and that at least those mistakes have less probability. In addition to that, we get some benefits like we are always having a clear version history, our versions are mutable, it's easy to roll back because it's just a Git revert, and all those nice things you just get out of GitOps. The tool that enables this for us is ArgoCD, and I just have a very, very short slide of what it is because probably you all know it. It's doing continuous delivery for Kubernetes. It's a GitOps agent or just a Kubernetes operator running in your cluster doing GitOps. And the interesting thing for those of you that are maybe using Flux is ArgoCD is using applications to track sources. So if you want to track a repository or a Helm chart with ArgoCD, for example, you simply define an application, you say, hey, please read from there, and deploy it to that namespace. And those applications can be grouped into projects. And that's it about what it is. Let's get into the more interesting part on how to do least privilege with ArgoCD. You could argue, hey, no users have access to our cluster anymore, so we're done, right? But actually, no. Because if we're trusting a Git repository, we really need to make sure that the configuration of this Git repository is on point. Because if I have a repo somewhere and everybody there can just push to the main branch without any review, without anything, it's basically good for nothing. Maybe it's even worse than before, because more people might have access to this repository than to your Kubernetes cluster before. So you really need to find a way to make sure that your repository configuration is on point, that every change needs to go through a pull request, that there are relevant reviewers for each change, and that nobody can also rewrite the history on the main branch because it's kind of important to have those immutable versions. And we are doing this with Crossplane, so a kind of infrastructure as code tool with which we are just creating all our new GitHub repositories. And if somebody would go ahead and change something in the settings, which nobody can because nobody has permissions, but if somebody would do that, it would get immediately reconciled again and would be overwritten. And like that, we have all our repositories defined in code, and we can always be sure that their configuration is on point and that we can trust them. Next, we are heavily relying on ArgoCD projects to provide boundaries. So I told you ArgoCD projects are grouping applications, and you can define rules for those projects. You can, for example, if you have a project for the Hello World team in your cluster, you can say, hey, this project is only allowed to deploy to the namespaces Hello World, dev, staging, hardening, prod, whichever you have, basically. And by that, you make sure that the Hello World team is not messing around with the workloads of any other teams. And in addition to that, you can also define the resources that are allowed to create in this project. So we know the Hello World team wants to build an application, so we're going ahead and we're going to allow list a secret, a config map, maybe deployment service and ingress. And by that, we know what the Hello World team is going to do. We have limited those privileges. And also, we are not using any wildcards here because Kubernetes is really, really extensible, which is a cool thing. But you never know which resources you will have there in the future. And this is the reason why we decided against wildcards and really going that cumbersome way of setting up everything. Yeah, so the Hello World team can push their cluster now. We need to make sure that they are not pushing any privileged containers, for example. Let's keep up this example. To avoid that, we are using Kubernetes policies. In my opinion, validating admission policy is really interesting as well, but we haven't adopted it yet. So with policies, we are preventing that anything that has, for example, a privileged container is getting deployed to our cluster, and if the Hello World team would try to do that, it would just get rejected, and they would have to fix it. To avoid this situation, you might also think about simplifying the user interface for easier policies and easier project definitions. So instead of giving out a secret config map, deployment service, and ingress to your users, you could create an abstraction for that actually hides exactly this standard application you have in your company and just give this to the Hello World team. By that, you make your own life easier with defining those projects, but you also reduce the cognitive load of the Hello World team. And last but not least, providing development environments is something really important, because we have noticed the situations where we and our users need direct cluster access is actually during emergencies, which we will cover a bit later, but also during development, where you want to have fast feedback loops, where you just want to apply something, delete it again, test if it's working, and so on. And by providing good development environments that also have all the tools installed that are in the production cluster, you make development super easy. And then, once development is done, you can just connect to the cluster, push your changes there. Nobody's messing around with your production cluster. Everybody is hopefully happy. This was also the state we have been in. And now, time for another story where we haven't been the smartest people on Earth. I like to call this the tale of lost mindset if you like dramatic titles. Basically, what we did is we implemented all of that, we had GitOps in place, we were quite happy, and then we continued working on our other epics and our other stories, and one of this was getting Crossplane to work. So basically allowing to create cloud resources via Kubernetes. And we did that. So we installed Crossplane in our Kubernetes cluster, and the first thing we wanted to do is create a database for Backstage. And so we went ahead, connected to AWS, because that's what we are using, created our IAM role, created a provider configuration that is referencing this IAM role, created our database. It worked. We were super happy. Next story, we needed a certificate somewhere. So what did we do? Connect to AWS, extend this IAM role, apply the certificate, be happy. Well, we repeated this cycle a few times. And suddenly we noticed, hey, what we're doing here is not least privilege anymore. We're having an IAM role that is this big, and with our SonarQube deployments, we could break our Backstage production deployment, which is just not what you want to have. And so we took a step back. We noticed that least privilege is not something you can do once in a story and be done with it. The same applies to Zero Trust. But you really have to get it into your own mind and into the minds of your team, and as part of the definition of your stories. And if there is one important thing about this presentation today, it is exactly this. Least privilege is really not something you do once. You need to get it into your mindset, just like testing or anything else, and it needs to be considered with each and every story, with each and every epic you are doing. Okay, so how did we solve this? First of all, the very quick what is Crossplane slide again. So it's just a Kubernetes operator, but in my opinion a super cool Kubernetes operator. because it allows you to orchestrate application and infrastructure from your Kubernetes cluster. So you can, for example, install the AWS provider, and then you can apply YAMLs to your Kubernetes cluster that will create an AWS database or a Google database, or like in our case, also GitHub repositories, so that we can make sure that our GitHub repo configuration is on point. Yeah, with these provider patterns, it's highly extensible, and the cool thing, it's not opinionated, so you can use it in your platform and build your own opinions on top of that. So how did we now fix this situation with least privilege and crossplane? First of all, again, we identified that we need to have a common mindset of least privilege. Second step was we favored composite resources over managed resources. In Crossplane, what you get from a provider directly is called a managed resource, and this one is always cluster scoped. And for cluster scope things, it's rather hard to define policies and project boundaries for us. So what we did is we created composite resources, created a bit of abstractions for our users in there, and then favored this one over managed resources, and the problem of writing project definitions was gone. And as the last thing, we just went ahead and split up our huge IAM role on AWS in multiple smaller ones, which we then actually also defined with Crossplane, because why would you do that manually? And then we created multiple provider configurations that each linked to one of those IAM roles that we created. And then you can just go ahead, bind those provider configurations to your namespaces, and you're good to go. No namespace can use a provider configuration it's not intended to use. And it was a super easy fix, actually. But still, it wouldn't have been necessary to do it that way, and it would have been much easier to do it right from the start. So that was our first rather big challenge we solved in this whole setup. But there are some really interesting future challenges that we need to approach and that I'm looking forward to in the future, actually. First of them is handling emergencies. Unfortunately, at the moment, we haven't found, or we didn't invest time to find a good way in handling emergencies yet. So, because what we want to have, if there's an emergency happening and we have GitOps, we basically just want to shut off the automatic sync, want to fix it manually, roll it back to Git, apply it to Git, and then roll it all over again. So just with breaking the glass mechanism. And also, we do not want to have permanent cluster access for our team. But we want to have something like just-in-time access. So this is going to be one of the most interesting things we are going to do in the next couple of months. And maybe I can tell you more about next year, let's see. Yeah, reiterating is going to be interesting. As said, least privilege is not something you do once and you're done. And also permissions changes, workloads change, and so on. So reiterating on that and staying up to date is going to be very interesting. One more time, I'm sorry, embracing the mindset. And with that all being said, least privilege is just the start. So there's so much more we can do in the future, like also continuing to zero trust, doing all this networking, containerized workload stuff I talked about in the beginning. And I'm really, really looking forward to doing all of that because I think it's going to be super interesting. And with that, thanks a lot for listening. If you want to connect, here's my LinkedIn QR code. And I would really appreciate some feedback from you, either via the QR code and the form of the organizers, or just personal later on, would be great. Thank you. And of course, if there are any questions, perfect. At the moment, we are only using validating because we didn't want it to be confusing for the user to also mutate things. And
right. There's a follow-up question. Because how do you show the user what they need to do in order to comply with the policies you have in place in a clear way? Because you see that they don't understand the message that they get back because they take it from something that works with root access on their local machine, and then as soon as they try to deploy it, it's like nothing's working.
Yeah, that's actually also one of the problems we have. One thing we did is when we get started with this, we created, of course, nice documentation where people can also look certain types of errors that happen often up. And we didn't make it sharp immediately because we didn't want to break all the workloads in the cluster. So what we did was, like in the first phase, we just created tickets for things that happen. And there it was easier for developers to fix it because they had the time, they could reach out to us for help, they could check this documentation. And after some time, when all existing problems were fixed, then we started to continue and make it sharp. And by that, somehow people also knew the errors already, because it's at our internal clusters, we don't have like a user base that's that huge, but it's more or less the same people always. So it was a bit easier for us to do.
I think that was around 3 or 4 months ago. We tried to use the Crossplane. At least not one of my colleagues tried to at least to see if we can replace it with a Terraform. It's because we already use the Terraform for a couple of stuff, but we would love to do it with the Crossplane. But we had a lot of issues to to run something in AWS, and a lot of like glitch and errors. I don't know if you have faced any of these.
Yes, we did. So we're using Crossplane quite heavily, and we really, really like using it because of the workloads it enables us to use. That's simply amazing in my opinion. But I also think that when using it, you really feel that it's like not fully stable yet. It's getting better each release, and 1.14 was just released, especially with some really, really good provider performance optimizations and functions which are very useful. So yes, we are also facing these problems. The good thing is we are facing them while setting things up, and then it's good. So we just embrace it, to be honest.
But at the end, we have seen mentioned some of these providers use the Terraform at the end.
Yes, that's like many of them are generated from Terraform, which also caused a lot of performance problems. But at least that part was fixed now.
So you use it in a production currently, right?
Yes, we are building it currently. So it's not running in production, but we are.
How does Crossplane these days deal with resource dependencies? We were trying to bootstrap our AKS classes in the past, where you have subnets and all that kind of stuff. How does it deal with that these days? Because it's eventually consistent.
We also had that problem, and we didn't really solve it yet. The good thing is in the latest release, I forgot the name of it unfortunately, but they have something that looks really interesting in that direction. I didn't try it out yet, so I don't know how good it is working, but at least you can see they are working in that direction. So.
You kind of touched upon the whole mindset, but how do you deal with, your rockstar developers who are adamant that they need access to your Kubernetes clusters, which obviously don't exist here?
To be honest, we just say no and don't care that much. So we're really trying to provide nice workflows around all of that to make sure that people have good alternatives. So we're not saying no and I don't care about you, but we're saying no and let me show you that and let me explain that and couldn't you use that. And at least people in our company are really understanding about that, and I think they like that we are working on the clusters and improving things. So, oh yeah.
Are you doing any additional observability work to sort of offset the lack of, insight you might have previously been getting from running commands in a cluster, for example?
Sorry, I didn't get the beginning. Any additional?
Observability work, in terms of exposing maybe more metrics or different.
Yes, we do. So actually, I'm working at Dynatrace, so we monitor everything we have in our company with Dynatrace. And yeah, we're just heavily using that one, and also use it for troubleshooting because. Cool. So thank you all for coming. I will be around and.